Record progress.
Hello, welcome to MyWebUniversity free education videos. On this video, we're going to continue on learning Linux operating system, and the book that I wrote is called The Direct Path to Linux Ubuntu. We're on chapter 4. Last time we covered chapter 4, part 5, which is on this video on the left side, in the most left side. It is already posted on YouTube. You're welcome to subscribe to MyWebUniversity free education videos. I really appreciate it. So just come in and then watch these videos and enjoy it and learn from it and make some nice comments so I can improve any area that it needs to be improved. My job is to help you out so you can succeed on your jobs as well. And today's topic, we're going to go and learn Linux operating system advanced level, chapter 4, part 6. So in order to do that one, we're on chapter 4. As you can see, on chapter 4, we have a total of 88 commands that covers the entire chapter 4. And on chapter 4, basically, so far we have covered the first row up to the 5th row. So about 55 of these commands with so many examples we have covered. Each row, which is 11 commands, I covered one session, one video. If the examples are a lot more, some of them, they have like 10 examples or 5 examples or something. Like for example, in the Docker section, we covered a lot more examples, or apt-get, and those ones for application stuff. So installation, like package manager, application programming tools, package tools or something. So here, this one I'm going to be covering today on part 6, chapter 4, part 6, which is that starting with GDB and finishes with LS hardware. Last time on chapter 5, we covered this 5th row, which was stat through swap on. And as you can see, the chapter 5 is already posted, part 4 and part 5. So we're gonna go on chapter 4, part 6, which is this row 6. There's altogether 8 rows, as you can see, which are 88 commands. But for each commands, I'm showing you a lot of examples. So for example, on the GDB GNU debugger, I will actually trace a C programming language. So we will, or C++ in this case, we can do both. So let's just go over the first row. But before we go cover all these rows, I prepared a nicer interface for you from Linux command line itself. I wrote some script, so I'm going to go through the scripts and show you what I have done for you, so you could enjoy while you're learning the videos. You have a nicer interface. Using bash scripting, I wrote some script to generate these tools for you, so you could learn easily. So the first page that you see is welcoming you to MyWebUniversity free educational videos. And if I, right now is waiting for me for a keystroke. If I press the key, then it's gonna go to the next page and it says, please subscribe at our YouTube channel. I really appreciate it. And I mean it, I really appreciate it. When you are subscribing, it tells me that you're interested to learn. Therefore, I could actually return the favor and just bring more nicer videos so you could enjoy learning it. And as you learn, you succeed in your job and support yourself, your family, your community. You're a very great asset in the environment that you're working on. So this is all presented by myself, Wahidullah Lutfi. My name is, in short, is Wahid Lutfi. And I always send love and peace to you all, everybody in the entire globe. That's what our job should be. We should all respect and love and cherish life and for the time that we are here. So This is the first page, which I did this script, and then the next script that I'm going to run is called chapter 4, part 6.sh. And this is again welcoming you to MyWebUniversity Free Education. The name of the book is called The Direct Path to Linux Ubuntu. We're learning chapter 4, part 5, which is the advanced Linux operating system command lines. So everything learning Linux operating system advanced level, chapter 4, part 5. And the advanced commands in this session that is actually is part 6. So I'm going to have to change that one. Let me just control C out of this and then VI. The chapter 4 part 6.sh, and then I just modify the part 5 to part 6 very easily. As you can see, I'm on a VI editorial, so I updated it. Now I'm going to run the script again, and it's gonna just show part 6. This is what I will be covering tonight, chapter 4 part 6. And the commands are gdb for GNU debugger, dd, which is for disk copying files and converting files. So you can even copy the master boot record or make ISO images from that command. The Deviant Packager and the Deviant packages like package managers, dpkg, kg. Deviant Packager or dpkg, and then there's the apt-get and apt-cache and rest of the commands that config and so on. All those ones we covered it last week, and then snap is also there. We're going to cover the snap package manager also, and then gunzip. Last time we covered tar or gunzip. Gununzip, gunzip is another command that we will cover. Syslog or rsyslog, and then vsyslog. All those ones will be covered. Htop is similar to top command, but it's a very nice graphical user interface. And then modinfo, the command htop is not advanced, but the concept of using htop and how you check on resources, that's advanced level. You have to know the CPU, the memory, the IO, the zombie processes, the process IDs, and trace them differently in order to watch your performance of the system. So whether you run top or htop, yeah, the command is just a simple command. You could run in -u. You gave it a root or user level and then get the output, whatever you want with those syntax. But the concept of how you monitor, how you look at your resources, how you find out zombie process, how you find out defunct process, how you see your system utilization at peak time, all of that one is kind of like advanced level that you have to understand it. Modinfo is for modules information, is similar to lsmod, to list the modules. We will cover that one. Snap, I already talked about it, is the Deviant package manager that is are all self-contained. The difference between snap and apt or meeting all the dependencies. So when you're looking at OpenSSH client to install it, apt will find out all the dependencies. For example, if it has the OpenSSL modules that has to be installed as well, and then it will meet those dependencies. It will download all the packages related to OpenSSL. But if you're doing a snap with OpenSSL or Firefox, the whole Firefox is a contained package, meaning that everything is included. It's a bigger package. It's a little bit slower to load, but once it's loaded, it's much faster. It's much easier to control, maintain, and it's like a container. NM is for symbol tables. When you're looking at shared object files or executable files to find out the symbol tables, you do that one. lsmod is similar to modinfo to list and the modules, and we talk about ls hardware is also to show you the type of hardware that you have. For example, -C for the class section that you want to see, like a disk or CPU and other ones. We will go through those examples. So at this time, this session, chapter 4, part 6, will cover all of these. This is what I'm going to be covering on this session with examples and everything, so you can understand. And each one of them we will just go through what is section of it, then cover it. So like here, I am pausing 5 seconds. So for what is GDB, you could see GDB, and then the GNU debugger, and what is DD, converts and copy a file. What is Deviant Packager? And the Deviant Packager is a package manager for Debian, and then section 1 of them is giving you the section. What 3 Perl is a different one. What is gunzip? Compress or expand files. The syslog, as you can see, it shows more for the syslogs, console logs, and clear kernel messages writing to the var log messages. The htop, we talked already, interactive process viewer. Modinfo, we already talked about the show information about Linux kernel modules. And what snap is tools to interact with the snaps, and snaps are self-contained packages. NM is the list symbols from object files. Object files are the object or libraries or modules that are listed. What is lsmod shows the status of modules in the Linux kernel. So to see the list of kernel modules, you could see it. What is ls hardware and list hardware? So you can see it's a very nice kind of interface here that I provided for you. For each chapters, when I cover a session, let's say for chapter 4, part 7, I'll do similar activities. So now I have a script ready. It's almost like automated, even for my training. When I teach you, I want to have certain format, certain look and feel of the class. So it will be interesting for you to just spend your time on the site or the website, or watch my video channels and subscribe and learn from it. Whether it's shell programming, or later on Python or C or C++ or MySQL, I'll do all of them in a very nice format and a nicer interface. So please join me and subscribe for it. And I'll just at this time go to the website, and just to show you what is available on the website. So on the website, if you type in click on GNU debugger, and then I'm just providing you a man page for the GNU debugger. Because if I just run some commands on the website, it doesn't make sense. A lot of these commands are interactive that you have to practice it. So I'm giving you the man pages. You can read the whole man page and practice it. But on this video, I'll show you what is GNU debugger from command line and parts of program in C++. So let's do that one first. I'm going to go to this one, and then just minimize this one again. And right here, I've cleared my screen, and I say pwd. I'm on home wlutfi. So I'm going to go to programs, and I'm going to go to C++. And then I say ls -l. I have a list of C++ files. So if I just want to see them in a nicer format, and then this program that I installed, it looks like in a nicer interface. So you can do that one. And now if I want to see the contents of hello and .c++, as you can see, I can do a cat -n hello.c++, and that would show the entire code of starting with IO stream to be included. And then the string module also is included, because I'm using a string to define these, a string 1 and a string 2. And then I'm just going to use the cout, because they're using namespace standard out. Once I do it, I don't have to put std and the scope resolution 2 colons and followed by the cout. So I could do this one and then just print out the string followed by a new line, and the string 2 followed by a new line, and then followed by another line. So this is the C program. If I just want to do the same thing with laugh out loud cat command, a nice looking program. So let's clear the screen here, and then we just run this one. And now at this time, I'm going to compile this program. So notice I have hello.c++. This is the executable. And if I say file hello.c++, this is just a C++ source code. I know that that's a C++ code. So I'm going to say which G++, the GNU ++, and the G++ is a GNU C compiler collection for C++. And then the other one is a GCC. That one is for a C compiler collection for GNU. So if I type in G++ dash version, you can see the version is a 9.4 that is there. And then similarly, if I just do the GCC, which is for the C compiler, is 9.4 as well. So we have both of them already installed. That means the hello world, like the hello world program that I have here, and this one, I'm going to just look for a program that's hello. I did not have a hello as executable, so I'm going to generate the executable. And in order to do that one, I just say G++ -O, and then I'm going to say hello is the output, and then from hello.c++. Now I just generated the hello file. As you can see, before it says no such file. Now, because of this -O, and for executable output, I created this hello, which is this executable. And then if I just look at the contents of hello.c++, you see that one now, file hello, which is the executable link format. As you can see, it is already available for me to run it. So I'm going to say hello here, and that will just say hello world, welcome to MyWebUniversity.com. And if I just do use G++ option here, without giving any name here, like this syntax, say just the source code, it will create a file called a.out. And then file a.out, because I did not give an extension with -O, the name of the executable file, to say by default it creates a.out there, which is also giving you the same output, hello world. So now this time I'm going to just rm a.out and hello program. I don't have both of them, but I'm going to do a GCC, I'm sorry, G++ -O, and then I'm going to say, I'm sorry, -G for debugging mode, so I can run the Gdb for GNU debugger. When you say -G, you're putting the debugging enabled. You're making a debugging enabled. So I'm going to say -O hello, and then from hello.c++. So this syntax of compilation is having the -G flag, which means enable the debuggers. So next time when I run the program with certain syntax of Gdb, I can just look into this file and Gdb. And now I have the file. Notice that hello is an executable link format. And earlier when we did what is Gdb, and then what is Gdb, and then we noticed that it says the GNU debugger, right? The GNU debugger. But then if you do a man pages on this one, it will just tell you that it is just basically looking for a shared object file. And this shared object file is hello. So I'm going to say Gdb and then hello. That's going to just open hello program, and then notice that the symbol is red. And then at this time, if I just say run, it will run it, and then it will just say hello world, welcome to MyWebUniversity.com, and exits normally. So at this time, if I just say start, again start, and it's gonna go on line 7 at the main function. So it goes to the main function, and then it says hello.c++ is there. Now if I say layout, next, and then I will see the list of the code, and this is the breakpoint that is saying it is opening from line 7 into the main, so it is going to do the code. At this time, if I just put on the GNU debugger N for next, it's gonna just go through, step through my code. So at this time, if I just print the string 1, it has not any have any value. I'm sorry, print string 1. String 1 does not have any value yet. So now I say next. Now it went to string 2, the next line 9. Line 8 is already executed, so string 1 is defined now. So if I say print string 1, then you can see that it says hello world. And then now if I just do a print a string 2, similarly, that is not defined yet, as you can see. And then now I say next again, it went to that one. If I just go print string 2 again, it will say that message that is welcome to MyWebUniversity. So then I say next, and you can see that it comes to return. At this time, print string 1, it is still defined. Print string 2, it is still defined because we haven't gotten out of the function. When we go to the return, the program finishes, and the scope of those string 1 and the string 2 completes. So those variables are defined within the functions. And then at this time, I'm going to just say next, and then notice that it went back to the other one. So still those variables are defined. Print string 1, and then print string 2, and then at this time I'm gonna just say next, and then one more time next, and next. Now the program completed. The program completed, and then it says that it is exiting the main. So now I have done everything, and if I say next, there's nothing there. It says program exited. And then if I try to print those variables, and they're not defined anymore because the scope is completed, as you can see. Print string 2 is not defined. That's good. If I just want to start all over, we can do another start, and then or just go to another things, or use the GNU debugger command lines to see more of the commands itself. So there's a lot of commands here available for the GNU debugger, but for one session, I rather just concentrate on covering the rest of them. And I'm gonna quit from this one, clear my screen here, and then we just covered man and GDB. The GDB, you can see here the GNU debugger. It tells you that it's covering the shared object files and those files. You can also do core files. You can also check, there's ADB for advanced debugger, MDB for module debugger. On certain ones, some of them are coming on your system, some of them you have to install it, some of them, or for example, advanced debugger on Solaris platform, and MDB and GDB or on Linux platform. So if you don't have it, you just have to download the packages and there. And when you do which GDB, you can see that it's there. File user bin GDB, it is just there. Type user bin GDB. It's just telling you that this user bin is GDB is the binary, and that's a shared object. And if I do a LDD on user bin GDB, it shows all the symbol, shared object files itself that are being used, all the SO files. So just see if this command looks a little bit nicer, cleaner on the thing. So you could do something like that too. So let's just go back to the next command. The next command was here on the GDB, was DD command, I believe. The DD command is very intuitive. It is just to copy and convert files. Sometimes you can convert files from lowercase to uppercase. Sometimes you can just copy files from a file to another file. or just copy files between the devices, or sometimes you just make a master boot record. Sometimes you use the DD to copy the entire disk. Sometimes you copy, in addition to master boot record, certain ISO images to make an ISO image out of a DVD. There's a lot of ways you can do it, and I can show you some of the commands. Let me just cover a little bit on that command as well. So let me just minimize it here. As you can see, when you say clear the screen, say what is DD, and then we just see convert and copy a file. So what does that mean? If I just look at man DD, it just tells you that the options that are there, you specify the block size, and then the convert block size, and conf is taking the conversion, whether it's the number of errors, no errors you want to see, no truncation, syncing, all of those ones separated by comma. The count, how many blocks you want to read, block size is defined, and then the input block size, sometimes you want to define it with output block size differently if they're not the same. The input files that you want to use, and then the output file where you want to use it from. So let me just, since we're on this directory under this, and we just say hello.c++, if I just make a copy of this file, I could just say copy hello.c++ with hello.c++.cp. So that is done by a copy command. And then now if I do a diff between the two files, there's no difference. And if I just do ls minus L bang $, that bang $, is telling me whatever was my argument, just use that one as the argument of this command. So now you can see there's files that are there for both of them, ls minus L .cp, and let me see what is the other one, why it only lists one of them. So let me just do a list minus L. It should have just listed both of them. Maybe it took the first argument rather than everything. Yeah, that's what happened. The $, bang $, takes the first argument of it. And then you could have $asterisk or $@ would just take the entire array. So here we are just using ls minus L, and you can see the size of the files are the same. There was no different except the permissions. I created this one with my permission that I have write access on that directory. So if I do the same thing with dd command, I say input file is equal hello.c++, and output file is equal hello.c++.dd. This is looking nice too. It just says, yeah, I created that file, and then I wrote, it took this much time, and I wrote 602 kilobyte. And now if I just say ls minus ld hello.c++.start, you can see that two files that are copied, including .star and hello.c++. All three of these files are the same size exactly. There's no difference between hello.c++.cp and hello.c++ and .dd. There's no difference. Similarly, there's no difference between hello.c++ that we copied from and the dd. And if I just want to say, okay, so the echo $? is saying that these are the same, I just had it. And then what if I just want to convert something from lowercase to uppercase? So you could say, for example, echo, let's say, this is a disk just for a lowercase. I'm not gonna write the for lowercase because then we are going to change it for uppercase. It's going to say for lowercase and uppercase. So the echo, this is a test, and then we say lower.text. So now cat minus n, and there's only one line on this one, lower.text, and it says this. So you could say dd input file is equal lower.text, and then output file is equal upper.text, and then the conf for conversion, you just say uppercase, and the conversion is there. Now notice that two files got updated, lower.text and then upper.text got created. They're both the same size, cat minus n lower.text, and similarly cat minus n upper.text. You can see one is in lower, the other one is in upper. Cat, I just type in both times that without the n. So the lower, let me just, yeah, the lower I wrote it correctly, but the upper was the problem. So let me just do like this. You can say cat minus n lower.text and then upper.text. You can write both of them in one line also. You can see that to line one of them we converted there. And if we just convert, let's say rm lower.text, and then we just say dd input file is equal upper.text, and then output file is equal lower.text, and that would just create a lower.text as we expected. And actually, sorry, I did not put a conversion. So when you do that, this one, you have to just say the conversion is equal lowercase. This one will just change that. And now you type in that one, and cat upper is still good. And then if you want to just see them together, lower.text, and then in a nicer look and feel for it, you can do that. And then you could get the output you want with a nicer color. So that is DD, and then we could do also from ISO image and mount it, that ISO image as a file. You can also create using DD the master boot record, which is the first 512 characters or bytes. And the master boot record contains the three parts actually. The boot kind of sectors that is going to initialization of the boots that comes in, and then the 64 bytes of it is the next kind of like a partition table of this. So the bootloader has to be on the first 466 characters, I believe, and then the next 64 characters is the partition table, and the last 2 bytes is the signature. But the master boot record, whenever you copy it, you just copy 512 by default. And DD, if you don't give the count in the block size, by default it is about 512 bytes. So, and then you can also create an ISO image. But some of those examples, I may do it at a later date because there's a lot to cover on each of these commands. We can allocate one session for one of these commands, and I could talk for it, and we are still not finished with everything to cover. So let's just go to the next command here. We covered DD, and then I'm going to go a little bit faster. The Deviant Packager, Deviant PKG that has the commands. You can see here I'm listing the OpenSSH client. And so when you do -l, it gives you the Deviant Packager OpenSSH, and then it has a lot of commands. It's like a lot of options. -l to list all the files and the binaries there. Similarly to like app dash list or yum list or DNF list command. You can check on these ones. But Deviant PKG is the mother of all kind of packager in Debian distribution. So with this one, you can do almost everything and that a snap and apt does, but there's a lot more than just a few commands that you can list it. So if you look at the manual pages here, and that list is going on and on so much with all those options like -s, uppercase S, and search and so on. So like, and let me just show you a couple of examples on that Deviant Packager. So let me just minimize this window here. And right here, if I just say, what is dpkg, and then I say, laugh out loud cat, you can see that shows you the package manager for Debian, this section 1. So I could do a man -s1 and the dpkg, and it will give me the entire package information for it. But let's just look at a couple of things. So we say, what is Debian pkg, and then I do this command to just look nice, and then we just do one more thing here. I'm going to say dpkg Debian Packager -l for listing open ssh-client to just see that package. And you see this option of -i, I mean, it's already installed. So if I say which open ssh, it's not going to show, but if I say which ssh, that binary is there. So user ben ssh dash version will tell, actually -v, yeah, the -v is going to tell you the version of that one. So then I say Debian pkg-l open ssh-client. We did that one. Now I'm going to do Debian pkg-uppercase l open ssh-client, and then that will actually list all the files that are there. So if I'm interested on the binaries, I can go scroll up, or I could just say, well, let me just do grep -i bin. So these are all the binaries. Like you can see scopy for secure copy, sftp secure ftp, ssh secure shell, ssh-add, ssh-agent, argv copy, keygen to generate the keys, key scan, slog secure login. So all of that one is just part of that open SSH client when you do it. And on top of it, SSHD for daemon is running if you are just connecting to the SSH and daemon through SSH. So right now I'm logged on with the system remotely, and I have come from this IP address. And basically, when you do who am I, it will tells you where did you come from remotely to log in through this SSH. So ps-efa grep -i, if I just look at it, this SSD is running it. And then if I just say lsof-p, and then just look at this process ID, and there, that is that, and basically the SSD, the current working directory where the process started, root exec executable. But all of this one is saying that is because I'm not root. So sudo, by doing sudo, now I can just get the detail of that process SSD. And you can see that all the shared object files related to it, everything is that's there. It's all intuitive and there. So we were looking at Debian Packager, and then I could say Debian pkg -uppercase s for open ssh-client. So I can search for it to say that where they are at all these gunzip files that are there, and then if they are installed, where the documentation is and everything else. Let me go back here and then go to the next command. And the next command, we already tested those examples, and we went through man pages, gun unzip. For gun unzip, and then tar, I already covered that session on this other video, tar, and then also with tar command, as well as that one was 1, 2, 3, 4, 5. That's chapter 4, part 5 for the tar. But then gunzip was chapter 4, part 3. So when we cover this one, I also cover the same documentation, everything. But on that video, chapter 4, part 3 on gunzip, tar and the gun unzip is already explained. And basically, gunzip is just to put it in zip format, and gun unzip is to put it unzip it. Tar is to do a tape archive. And I did a lot of video on those ones, so it is just a repetition. Please watch this video for details, or this video for tar. This one, gunzip, covers both gunzip and tar as well as gun unzip. So all three of them are covered. The syslog, let me just see, yeah, and then there's also here examples that I'm doing it. So it's not like anything difficult with that, very easy. You create the tar files and then you extract it when you need it with that -xvf, and then you put it with displayed with tvf, and then with creation cvf. Those are very easy command. Gunzip is to format the file. You give the gzip with the file name, and then it puts the file name with the gz extension, and use gunzip to unzip it. And then there's a -d for decompressing it, and -c for compressing it, and the compressed level is 9 is the highest. So you could all look into the man pages and practice with them. They're very intuitive. Syslog D and syslog. So in this case, we're going to just talk a little bit about syslog, R syslog and everything. So if you look at the syslog, this is the older version of syslog, and it's replaced to R syslog. And then whenever you are writing to the sending message to the system log, then these include syslog.h header files. This is inside your C or C++ program that you're doing it. But the syslog itself, so if I say -s1 r syslog, or syslog d for syslog d is, let's do r syslog d. For r syslog d is the file is for reliable and extended syslog. So that is actually the etc r syslog d replaced the syslog stuff. And as you can see, that's on section 8, not 1. That's what was the reason that my program did not find section 1. So if I had done -s8 and then r syslog d, the function was there, it would have printed this one on the screen here. Similarly, if I'm just doing it here, and then I say clear the screen, man sys r syslog d, and then the daemon, that's why there's a d. If you do a man r syslog, there's no such thing, but the daemon is just responsible, and then the files that is using it is etc rsyslog.com file. And then you can do also man rsyslog.com file to just actually see the syntax of the rsystem.log.com file, which is how you are just going to add the entries in there, how you want to monitor them, and the var log, syslog, all the related stuff are here. Okay, so let me just go back to this other page. This is mostly a setup that is already done on your system. You just configure it with log rotation and your cron jobs and monitoring tools, and how to just watch for the var log secure, var log syslog, var log messages. All those logs, you configure them. There's a lot of logs on the var log directory that are very important files also, var log btemp and other utemp and all those ones. So let me go back to the next command. Sorry, my lips are getting a little bit dry. My tongue is getting. I need to drink some water, but I'm going to continue with this one. The htop is just basically a graphical interface that does you can do the man pages here, and then it's as I mentioned, this is just a tool that is going to give you as an admin or a senior admin kind of resources that you can run on your system. Htop, and you see a graphical interface, nicer interface. So the process IDs are showing on the left, the users are showing which are the users, priority, nice, the virtual memory, and that are on the heap, what's happening, resident portion of memory, shared portion, all those shared objects and libraries that come and go, the CPU usage, the memory usage, the time stamp that started the actual command that was there. And then on top, you can see the task and the high uptime, load average and everything. And then the memory usage and that swap and everything. So, and then you can also just use these functions and look at like F5 would give you a trees kind of things and sorted and so on. But then you can also do a htop minus u, let's say wlitfy, to just look only for wlitfy processes. And notice that the system D process that I started with the sshd and running this last process htop. So if I just change that one to a root to check on the root, yeah, I can see the process for root there. You can trace it different ways and then everything. And then free-h will also give you similar memory usage of how much memory you have and how much swap was there. Whether you run top or htop, some of these informations in terms of memory or CPU and everything is there. Uptime also, you need to compare the uptime here. With htop and htop and top, you can also check to see if there's any defunct process, or like top will just say if there's any defunct process or zombie process. The zombie process, or if they are there, usually on the system, they come in first as a defunct process, and then when they and the parent process ID become an orphan, or dies, the child become an orphan. And then init take care of it, and now init is changed to system D, which is the process of one, which is the mother of all process, will try to give the resources for that orphan child process. And if it doesn't just release the resources and still wait, it could become a defunct process. Sometimes we call it runaway process. And then if you trace it and find out through LSOF, list of open files, to find out what is the defunct process and which process got spawned, what is, you can do a dynamic tracing, not dynamic tracing, strace on it, similar to trace command or Solaris. But strace would just show you all the function call that's happening on that one. Then you can see, yeah, that function and the program is actually hanging. And then you can do a pkill on it or kill -9 on it. And if it doesn't, if it becomes a defunct that it returns to zombie, then you're not able to kill the zombie process. And Linux, unfortunately, sometimes those defunct zombie process, if init tried to reclaim the resources or gave the resources that that process needs and completed the sample tables and clears it for you, does a great job, then zombie will become 0 again, and you're able to keep the performance as it is. But if the performance drops and then the zombie process keep generating more zombie process, then on Linux, the only solution is to reboot the machine, which is not a good solution. On the Solaris machine, I remember in 2003, I was Solaris certified. And when you are like taking all those courses to just complete that successfully, and we were reading a lot of details on the kernel level. So I was like one of the people that could use ADB, MDB, GDB, and TRAS and all those kind of processes to just figure out what are the zombie process on Solaris. And there's a very nice command called preep, process reheap. preap. Preap command on Solaris that's not on Linux or Mac. In that process, you can actually reclaim the resources from that zombie process, and then that zombie process will be reheaped from the kernel, and then the resources will be given back to you, and the defunct process or zombie process will die. It will not just come as another process that it does on Linux. So you don't have to reboot Solaris machine when you have a few or 10 zombie process. You can pre-reap on the zombie process and you will be good. So, and you can trace all these processes as well with the details of it. With strace, for example, pwd, I could do like check this command, it prints this one, but strace on pwd, you could see the output of it. ls-l, you could say strace ls-l. I could just do everything, strace like top, then you can just get the output of the top. But since at the top, until I type in Q for quit, it will just continue just going through that one. But all those function calls, then you're reading it and you see that where the file descriptors are, what is, and the IOCTL is happening, the read, the write, all the file open, file close, all of those ones are happening, and then you can trace it further. With trace or strace, those are very useful programs that you can do it. And Solaris also has dynamic tracing that other systems, like Mac also has dynamic tracing and ZFS together along with Solaris, because they're based on BSD operating system. So we are covering the next command now. The next command is, this video is going to be a little bit long. I thought that we are going to be done faster. Modinfo and then snap. So let's do a few of them faster. The modinfo, for example, is already built on the website. So I'm going to check on that one. And you can see I'm showing you the examples of modinfo-h for help, and then -v for verbose. And let's go to modinfo for and -l to list xtcp dump. And then you can see that option is saying that x-tcp and tcp udp is GNU, general public license. The -l for license of it. If you want to just see the license, you do -l. And then -n is going to give the name of the file that has the package there. And so that is there. So you can do modinfo on these commands and then look at the info there. I don't need to do the same commands on the Linux, and just to give you this. So let me, while I'm covering modinfo, I'm gonna just clear screen, say what is modinfo, and then so you can see modinfo shows information about Linux information, kernel information. Modinfo minus, you can do modinfo missing module file name. So you could do modinfo with sudo and say -l for, I have to give a name of the this. So now let's do lsmod. And lsmod is going to give me all the modules. So once I have a module name, like let me just do this more, and notice that the names are all there. So one of the module for TCP and UDP that we looked at it from the command line, we can look at that one, or RAID 1 or something. Whatever packages that you're looking at, you could just get the modinfo on it. So we could just say modinfo and then -l XOR. The XOR is the license for this. XOR is also general public license. So if I just do a -n, and it will give me the file name, modinfo. And similarly, if I just do for RAID 1, RAID 1, you can see that is RAID 1.ko kernel object. So you can do also -L for the general public license. And then lsmod gives you all of them. And if you do a grep -I for TCP, so to just look at all the TCP modules, or just see for like interface E1000. E1000, you could put 100 and it still picks up, or you put 1000E, it will still pick up. So lsmod -L, and then we can say E1000E. That would not lsmod, modinfo to get the license information, and then it says general public license version 2. And similarly for the name of it, we could just get that name, that path to the actual library where the module is. So if I do a file on this long name, which is under the module directory, you can see the type of file this is. It just says kernel drivers, and then version system 5, and then build. All the details are there, executable link format, 64-bit, and so on. The reason it says 64-bit is because all the operating system here is the machine type architecture, and CPU and everything is there, x86 64-bit. So the next command, we covered lsmod and modinfo together. Let's just cover the next one, snap and nm, and then ls hardware. So ls hardware, since we are talking about here, I'm going to cover that one next. Clear the screen, and ls hardware -C for class, and then I say disk. So notice that I'm not a super user, so I could run a sudo command in front of it, sudo, and then it will just prompt it, and then it will give me the definition because I typed the sudo password earlier. So now it says that if I'm looking at the disk, all the ls hardware for the disk is going to show the type of disk that I have, dev SDA, and then other ones. So I can also do ls block to see the disk information, like SDA1 and SDB1, all the devices that are there on the disk, and the file partition, everything, and the volume group display is there, the name of it. Let me just do sudo in front of it. And then this is the volume group, and then so you can see that the volume group 00 is there, and then volume group display, we did it, and then we could say logical volume display, and then you could see, let me just do again sudo, because these are high privilege. So you can see the /home and everything that is there. All these devices that are mounted on dev SDA and SDB, as we saw it on ls hardware -C disk, we saw that one. Again sudo, and then you could see that there's there, and then sudo ls block is giving you the same kind of information here. Okay, let's see what we could do. Clear the screen, we say ls hardware -class, and then we say CPU, and then I'm going to make it in a nicer color. So you can see that when you look at the running the command, let's just run it with sudo in front of it. And then you can see the output looks very nice, and there you can just get the information there for the CPU and everything. Similarly, we can do for the other commands, like clear the screen, ls block, and then look nicer in there. And then let me just do sudo again. Sudo is sudo ls block. So ls block. Yeah, that's a little bit too much for the laugh out cut, because it is more than one page and it is not getting it. So the next command was nm. Nm is man. Nm is the prints out the symbol table. list symbol table from the object file. And you can have these options of D for dynamic, and then like whatever parameters you put on in these ones, you get certain kind of formats for the output and there. And then some of the options are whether the symbol table is defined would be a D like here, and then if it is initialized will be a D, and then if it is not like defined, it would be a uppercase U for undefined, like we see that is undefined. So all of these options are there with the symbol table. But what is a symbol table? So clear the screen. What is NM? NM is says list of symbol table objects. So let me just do a nice look and feel of it, and then I'm gonna be looking at hello program, file hello. This is a program that we just did it, and then it is a symbol object file, executable object file. You see that object file. So it's executable link format 64-bit. That means I can do an NM on the hello, and then you can see all of the function. Remember, the main function is part of the every C or C++ program. So one of the symbol is a main. And then if it's T means it's a text type of it. If it's U means it's undefined. If it's D means it's defined. So I can do a symbol table on NM and look at all of them, and that are there, the definition, and then the type, the actual memory address that they are getting loaded from, and then that one when they start running on the program. So that is there. And then in addition to this, for example, if I say which, let's say GCC that itself. So file user ben GCC, that's a symbolic link file. So if I do ls -l user ben GCC, the actual file is a user ben GCC-9. Let's see if that is symbolic link to something else. Yeah, it is something else. So the actual file is user ben, and then in this one x86 64 Linux. This is the actual file. As you can see, file, this one is the executable. So if I just do NM on that one, you can see all the and then type more and no symbol table. So user ben 9. Let's see if there's anything. Oh, there's a yeah, that does not have any symbol table. It is if it is not defined with the within that, you will not see it. So let's look at the lep 64, 64, and then lep c star.so. Let's see, lep 64. Yeah, lep 64 is symbol link to something else. Let me see. Okay, so under the lep 64, what do we have? Sudo it's only showing one file. Let me see. Lep itself is, yeah, lep itself is there. So star.so, and then that is a lep dump and lep c. Let's see if we see anything with lep 30 64. We should have a lot more than let me see, lep 64. Yeah, actually it's only one file here, so I'm going to look at that file, say that this is symbolic link to this one, user lep GNU 64, and that is actually all the libraries that are there. Yeah, so it's only one directory that was symbolic link to. So lep c star, you can see, for example, for lep c, and then this file is there, but the actual binary is lep c-2. So if I say lep c-2 3.1.so, you can see that shared object. And if I do the same thing for nm on it, nm to look at the shared object, no symbol table on that one either. Let's see if that one is not actually like a C program that was compiled. It's a shared object file that needs to be linked with the loader to another program in order to run. So and they are kind of in this loader is going to the actual linking at the time of runtime. That's what's happening there. So if I just do the type of this one, it says it is x86 64 this thing. So let me just do file this one. Symbolic link also. So that is a file to this one. And that one is ELF64 shared object. So let's see if this one has the symbol table, because it says it's shared object, nm, no symbol tables, dynamically linked. Again, when it is linked with GNU, the loader will just load it at the time of runtime. So I was also checking on one more thing for nm. We did the file type and the symbol table. So let's see one more thing. I was checking for we did the ls file, and the type of this one is, I'm going to say type, it is linked to this file. And then oh, I wanted to do LDD on it. That's what I was that shared object file, we could do a LDD on it, and then that's why it's statically linked. When it is a static link, it's not shared object. So there's a static link and then also a shared object. Shared object.so, or if it is a statically linked at the time of compile time, and they just statically linked. But when they're dynamic linked, they're at runtime. So the loader does it there. A lot of the symbol table is when it's statically linked, there's no symbol table, everything is defined statically. So there's a static function, and see another ones that are taking care of that. Let's just go back to the last one. We covered nm, lsmod. Oh, snap. Snap is very good command that we are going to cover and then end this session. So clear the screen and we say what is snap, and then we do a nicer format. So, and that is as a tool to interact with the snap. So if I just say snap list, you can see all the packages that are there. Let me just do a nicer format. Actually clear my screen here, do snap this, and then say snap list, and then run this command. So we are seeing the sudo. Notice that some of the commands are just showing the and this command, because it's not trying to reformat the output to another format with this. But if I just do it without this, it will run the command. It will just show the output there, because some of them are just a little bit maybe containerized. So it self-contained, and snap is one of those packages that everything, all the dependencies are met within the package. So you can just do snap, and then with the snap you can do snap -- help. You could see all the help commands like find, info, install, remove, list, and everything. So let's just check a couple of them. We say snap info, and then at this time we say Firefox. If we just run the Firefox, basically it's just going to say, well, Firefox is there, and then its publisher is defined, everything. So we say snap a list Firefox, or actually show, snap show Firefox, and then show was not defined, and then snap find Firefox. So find will just search for snap, and then remember your friend snap dash help. So this one, the command info we did list, we have to check it to see if it is there or not. Show and list is there, but I believe I run that list, and then it says that somehow no matching, so it's not installed yet. So I'm going to do sudo to just install it with sudo privilege, and I'm going to say snap install Firefox. This will just go and install Firefox, and when it is downloading the package, it is all self-contained. It's not like apt. And when the package gets loaded, the entire package gets installed, and once you're done, you have the entire package as a self-contained package. On the contrary, apt will just find out every dependencies for that package, and then try to make those packages for you. And then as it gets the package, then you can just use it there. So right now it's saying that it's 100%. And then Firefox, it's mounting it and setting up Firefox and doing the channel. Okay, I'm going to just open up another terminal here, and just to see the same interface. And now let me see here. And I'm going to this one just take a while to install it, so I'm going to leave it as it is, but hopefully it will be installed faster. I should have installed. You can also do like snap, for example, find and then browser. So with the browsers that within the snap, you can see that is there. Like if you say Chromium grep minus Chromium, so I could install with snap Chromium, which is Chrome, or I could install Opera there. And then I can also do snap find, for example, PyCharm dash community, that is there, or code version, Visual Studio Code or something. So you could install a lot of the packages that are there by doing a find on them. And if it's not there, it will install it. Here, this one, it says now installed. So now we installed it. If we just say, okay, we installed it, that's great. Now let's see which Firefox. And then you see that snap ben Firefox. So if I say snap ben Firefox, and it is just saying that it's there with a symbolic link to user ben and file user ben snap, that's actually a package of binary. And if I do snap list Firefox now, because it's installed, before it was saying it's not found, and then it's there. Now if I say snap info Firefox, and the details are given to me, saying that, let me just do 5 more on it so we can see the entire things. It say name Firefox, Mozilla Firefox browser, and all the details are there. Here we can just press enter and get it there. So if I want to just spin off Firefox, I say which Firefox, and that means I can type in Firefox here, assuming that my browser is set up. So my display is set up. I am on a Xterm. So here I'm going to run xming. So you could do a terminal emulator, or if you're running VNC or Tiger VNC, then yeah, on the browser, because the remote server is in Germany. So if I just say, who am I? And then now I could just say, Okay, let's just go to my home directory, and then I just go to programs, go to shells, and then right here I have this my xterm.sh that will just spin off a number of extra terminal connections, so that each term I could run a different process with it. I can even run the commands here at this session, and it will opens that one for me, a number of xterm. So like, for example, like I just type in xterm minus bg, and then I noticed that those ones came in as I was trying to type in. So right here is all these terminals, and if I say xis, it will just open a xi for me right here. And then if I just do similarly let's do a Firefox to just open up Firefox here, and then cannot display localhost 10. So somehow the display is not imported here, $display. So I'm going to just close these ones, and then df. But you can see here a snap list. I can run the commands, no problems there. So I can say which snap here, snap list. All these commands work really nice. And then for this command, uname -a, clear screen. So the clear screen, the reason is because of echo and $display. So the display is there, and then echo $term is saying that vi. So I need to change to, and the export term is equal vt100, and now I can do a clear screen. As you can see, I can run the command and then clear screen afterward. See? So it's really nice interface. You can do a lot of stuff here with this. And then let me just exit out of this as well as this. And then on this one, I want to just run the other shell script called, let's see, I'm gonna resize this one, this size, and then I'm going to go here on my program. I say piece and .sh, and then so it writes that one in a xterm session, and then you press enter, and then love and peace. But let me just close this session and show you the same command here, depend on your interface, and then you could do certain things. So clear here, and then we say which Firefox. Let's see if Firefox opens on this one. The display, again, it is not setting here, but I can do xming to see if the display. So the display, when it comes in, xming has to be running in order to get that display. Let me just see if xming is coming or not. And then I'm going to open a new terminal and then say term. Yeah, cannot load fonts -ms max medium. So the xming software is not running for some reason, and I have to just reinstall xming for software that is actually, it did open it, so it is look like xming is on the side, is here running. Let me just double check on the task manager. On this is Windows. Yeah, xming is running, so that's why this terminal open. And then if I just say Firefox and this one, again, the local host Firefox is not coming to that 127.600. So clear the screen. I say who am I, and I'm gonna say export display. At this time, I'm gonna say, let me just do echo display first, $display. So that's 11.0. I'm gonna say export export and display is equal this IP address colon 11.0. Now I say Firefox, and that already exported my display. It should open Firefox for me on exporting it on my terminal emulator. It's gonna take a little bit because I set up my display. Let's just wait for that one, and at the same time, while that one is loading, I'm going to open another terminal here and just wait for this one and run this other command here. So while Firefox is loading, I think it is opening, but it's taking a while. Firefox is a big memory consumer. Firefox, yeah, you can see the process is started as this. We can do trace on it and everything else. Since I started from this directory, wherever I was, I can do a pwdx of this process. But since I started from Wahid Lutfi, and then it says the /home Firefox. So that is all good, and everything is good. And this time, while that one is loading, I don't need to wait for it. I'm going to just make this screen look nicer for you by just displaying one thing at a time. I'm gonna cd to my main directory, and then I'm gonna run the command piece and .sh. So this one will just say, thank you for watching my YouTube channel, MyWebUniversity Free Education Videos. That's my YouTube channel. And the URL is here posted. So please join the URL at YouTube, the one that I loaded here. And this is the MyWebUniversity Free Education. The URL is this, and then subscribe and like and make comments. I really appreciate your subscription and watching our videos. Thanks for watching. And then again, my name is Wahid Lutfi, and I'm providing you this love and peace to you all, and free education at my MyWebUniversity Free Education YouTube channel. Thank you all. Have a great evening, and have a great time, and love and peace to you all. So please join at MyWebUniversity, like and subscribe. I really appreciate it. Thanks. Take care. Bye-bye.